evaluate the following limit. We have the limit as x approaches 0 of sine of x minus x all over x cubed. So we'll go right ahead here and evaluate, replacing every x with 0. So this becomes sine of 0 minus 0 all over 0, which leaves us with 0 over 0, which is nonsense. This is undefined. It's an indeterminate form, which allows us to apply L'Hopital. So we can now apply L'Hopital's rule. So we are taking the limit as x is approaching 0 of sine of x minus x all divided by x cubed. And we apply L'Hopital. So we are taking the derivative of the numerator and denominator separately. So I have the limit as x is approaching 0 of cosine of x minus 1 all over 3x squared. And again, remember, we always have to evaluate in between. So this is cosine of 0 minus 1 over 0. And since we know cosine of 0 is 1, we end up with 0 over 0, which again we say, or we know, is undefined. Right? It's an indeterminate form. So we can go ahead now and apply L'Hopital's rule again. So we are taking the limit as x is approaching 0 of cosine of x minus 1 all over 3x squared. And we are applying L'Hopital's for the second time. And so this becomes the limit as x is approaching 0 of minus sine of x all divided by 6x. And we can go ahead now and evaluate. So this is going to be minus sine of 0 all over 6 multiplied by 0, which again we see is undefined. It's an indeterminate form. But since we've shown that it's indeterminate, we can apply L'Hopital's rule again for the third time. So we could say that this is again squared. So we are taking our previous step, the limit as x is approaching 0 of minus sine of x all over 6x, and applying L'Hopital's rule, we have the limit as x is approaching 0 of the derivative of the numerator, which is minus cosine of x, all over the derivative of the denominator, which is 6. And this time when we evaluate, we have minus cosine of 0 over 6. So we know that cosine of 0 is 1. And hip hip hooray, we are left with a beautiful final answer of negative 1/6.